Hello everyone, here we will see how to quantify the electrolysis process. So if there is a question that how much grams of one metal deposit on the another metal in the electroplating using electrolysis process, so how we will solve this type of question. So basically we have to use some good relationship, and there are the current measured in ampere, because in electroplating we apply current. So and current is measured in ampere, which is equal to 1 ampere is equal to 1 coulomb per second, and we can write like A is equal to C upon S. Ampere is equal to coulomb per second. So 1 ampere means 1 coulomb per second, 2 ampere current means 2 coulomb per second, and 10 ampere means 10 coulombs per second. So like that this will work, and we can convert from ampere to charge, which is in coulomb, and then we can convert this coulomb charge into number of moles, how many moles of electron we are pumping in the electroplating process using this Faraday relationship. And then if we rearrange these equations, we can come up like coulomb of charges will be equal to ampere multiplied by time in seconds, and number of moles of electron will be coulombs of charge per Faraday. So we have to use this value 96,485 Faraday here. So if we are going to solve this electroplating process, we can convert current in ampere, which is and time in seconds. We can convert this ampere current into charge, and then we have to convert this charge in coulombs into moles of electrons, and number of electrons, how many moles of electron we are pumping in the electrolysis process, and then we can find out how many moles of substance oxidize or reduce with these many number of moles of electrons, and then from number of moles of oxidize or reduce substance we can get the quantity of substance that oxidize or reduce. So let's see an example, then we can understand this process better. So if there is a example here that in this question aluminum is produced by electrolysis of salt like aluminum chloride AlCl3. If we apply 2.00 amps, which is ampere, of current for 10.0 minutes, what mass of aluminum may we collect? So this is the electrolysis process, and 2 ampere of current is providing for 10 minutes in the electrolysis process, and we have to find out how much aluminum we will get on cathode. So reaction at cathode will be, so this is a reduction reaction which will happen at the cathode, and the molecular mass of aluminum is given 26.98. so we have to use those key relationship. First we have to convert this number of charges. We have to find out first number of charges by multiplying amperes. So 2 ampere of current is passed, so 2 ampere and multiplied by time in the seconds, so they use 10 minutes here, so we have to convert 10 minutes into seconds. So how we will use this 10 and 1 minute has 60 seconds, so multiplied by 60, so total will be 600 seconds. So when we will multiply these values, it will come 1200 coulombs. So from here we convert all these 2 amperes of current into charges like coulombs. Let's see then what we have to do. We have to convert these number of the coulomb of charges into number of moles. So we have to use this relationship, moles of charges is equal to coulomb of charges divided by F, which is Faraday, and since we have calculated coulomb of charges 1200, so we have to use this value here, and divided by 96,485 coulombs per mole electron. So this is the unit of Faraday. So from here coulomb will be cancelled and mole of electrons we will get when we will solve this one. So we convert the current into the charge, and now we got the how much electrons, moles of electrons we are getting from these number of charges. So the number of moles of electron will be 1.244 times 10 to the minus 2 when we will solve this math. And then after that we have to convert these how much aluminum will solidify or deposit on the cathode by this relationship, that moles of electron divided by number of electrons. So you can see 3 electrons or 3 mole of electron are required to reduce 1 mole of aluminum ion. So we have to use this 3 electron here, and number of moles of electrons which we are pumping in the electrolysis process is this 1.244 times 10 to the minus 2 moles electron. And then electron will be cancelled out, and then this will remain, that 4.146 times 10 to the minus 3 moles of aluminum will deposit. So from here we got the how much aluminum will deposit in the moles. And now the last part of this question is we have to convert these number of moles into grams. So we have to just multiply these number of moles of aluminum by molecular mass. So you have to just multiply this 4.146 times 10 to the minus 3 moles multiplied by 26.98 grams per mole, and mole will be cancelled, so answer will come in the gram once we will solve this problem. So these are the steps are involved in electrolysis process to quantify how much one metal will deposit onto another. And one more way to solve this question, that is the using dimensional analysis method. We can also use the dimensional analysis method, which is very easy. You can figure out like this: x gram of aluminum will be deposit based on the time. First you have to convert minutes into time seconds, 60 seconds in 1 minute, and then we have to convert into charges, so 2 coulombs per second, and then we have to convert how many number of moles of electron we are getting by dividing Faraday's value, and then we have to convert how much mole of aluminum we will get by dividing number of moles of electron required, and then we have to multiply by molar mass of aluminum, and then we will get the value. So if you will cut, you can cancel all these common units. Coulomb will be cancelled here, and number of moles of electron will be cancelled out, and then aluminum mole will be cancelled out, only grams will remain. So when you will solve all this simple math, the answer will come exactly same, 0.112 gram. So this is the way you can calculate how much one metal will deposit onto another metal or any electrode. So this is the method how to quantify the electrolysis problem.